Welcome to the series about energy. We're continuing learning about energy in an effort to remove politics and learn how we can make good choices about energy and climate. Today, we're starting to talk about windmills, how they work, and how they might affect the climate. So windmills, they have been around for a long time. They're pretty cool looking, they're beautiful, and they become the symbol of green energy. But first, we have to talk a little bit about how wind energy is made. Wind energy is primarily driven by the sun. There's some other stuff like the Earth's rotation and other factors, but it's primarily driven by the sun. The sun heats up the surface of the Earth as the Earth is rotating around, the course of a day. And the sun going over the land masses heats up the air more than it does over the water. And because the hot air being heated by the sun is less dense than the cold air, it's like a hot air balloon and the heated air rises. And then the cooler air from other places like over the water, over different parts of the land, will come in and take its place. And this exchange of the hot and the cold causes the winds to form. And then due to variations in the Earth's terrain and water and valleys and this sort of stuff, you can have places where there's very predictable winds that kind of come in every day. And this is the kind of place that you really want to be putting windmills for capturing wind energy, right? And here's some graphics about what happens on the land. If there's no water, the sun heats the earth and the air, and then the air heats really quickly. And so as the hot air rises and goes away, the cooler air will come in and try to take its place. And so you can draw cool air from like over the oceans or whatever over into these hot valleys. Now, if there's water, that's a little different because now the sun's energy is going into the water, and all that energy really gets absorbed into the evaporation process. And so the air doesn't rise in temperature very much, but you'll get a lot of evaporation of the water, and that the evaporated water will rise and this eventually turn into clouds. And so the moisture that's being evaporated from the water goes in the air and it forms clouds, and then that air that's saturated with water is actually lighter weight than dry air that's the same temperature. And so these clouds can rise and they can transport really large volumes of water across land masses. I mean, you can send water hundreds or thousands of miles. And really, that's what makes life on Earth possible, is this ability to transport water through the air. And all it takes is evaporation, and it becomes lighter. So here's some things about air that are important to know. Even though you can't usually see the moisture, it's actually there. The air will be invisible as it absorbs moisture. It's kind of like a sponge, up until the point it becomes saturated. And then once it's saturated, it can't hold any more water, and that's when clouds begin to form. Now, as air is hotter, it can absorb more water than cold air. And for instance, saturated air at 90 degrees will hold almost 2.5 times the amount of moisture in it as a 60-degree saturated air does. And as air goes over a mountain, just because of the laws of physics, the way things work is that the air will become cooler as it goes up a hill. And so as the air becomes cooler, now it can, like if it can hold more water when it's warm, well then now it has to drop some of that moisture out, right? Because it's getting cooler. So some of that moisture is going to start to drop out. And clouds are going to begin to form and maybe some rain. So this temperature drop occurs, it's like between 3 and 5 degrees for every 1,000 feet. So it's quite a bit of temperature loss as you go up these mountains. Now, if you look at like the bigger picture, like if you're by a coast or a big lake, so there will be wind that drives the air towards the mountains, and that wind is going to be really saturated because it's been going over this big body of water, right? And so as it hits the mountains, it's kind of driven up just from the forces of the wind. And at the same time, there's colder air that's up in the atmosphere, and so the hill will cause this mixture to happen, and these clouds will form right at the hills. And you can see this out in the ocean when you're looking at tropical islands. But this mixing will, there'll be cloud formation, and then there will be even rain that occurs right along the hillside. And you'll see there'll be a side of a hill which has a lot of moisture, and that's because the air is rising and getting colder, and so it will drop out moisture on the way up a hill. But then as it goes over to the other side of the mountain and it starts going back down the hill, well, now it's actually going to warm back up, because if it's going to lose temperature on the way up, it actually gains it on the way down. And so then you'll find that one side of the hill has more moisture, and then the other side is drier and warmer. Well, the wet side it's really important because that moisture enables you to have like rainforests and other big sources of vegetation. And this is all just from what's going on here with this wind that's being pushed in with lots of moisture and just the way it works with climbing up the hill and dropping temperature and mixing and stuff. This is really kind of really important to the whole ecosystem. Now that we see how wind is made, next we're going to talk about windmills, how they're placed, and how they might affect the climate. See you next time. Thanks for watching.